Hello everyone. Welcome to this video on learning mathematics through concepts and examples. Today, we are going to explore derivatives with some examples. So let's get started. Here is our first example. We are asked to find the derivative of the function f of y equal to 4 tangent y minus square root of y over 6 minus 12 over y raised to 4 times square root of y, both of these in denominator. So let's rewrite this function. So we have f of y is equal to 4 tangent y, then minus, I can write the second term as 1/6 of square root of y. Okay, divided by 6 means 1/6. And then we have minus 12. And in the denominator, we have y raised to 4 multiplied to square root of y. Square root of y means power half. So 4 and then half, a total of 4.5. So in the denominator, we have 4.5, y raised to 4.5. But if I write it in the numerator, then that can be written as y raised to negative 4.5, negative 4.5. So if we write like this, then it is easy to use the power rule. So now the derivative would be, we can write like this, f prime y equal to 4 is a constant. We can write as it is. Now the derivative of tangent y is secant squared y, then minus 1/6 multiplied to the derivative of square root of y is 1 over 2 times the square root of y, and then minus, for this one, we can use the power rule. 12 is a constant, it will stay there. And then what we do is we bring this power in front and multiply. So negative 4.5 multiplied to negative 12. Negative times negative would be positive. And then 4.5 multiplied to 12 is 54. And y raised to, we reduce the power by 1. So if you reduce the power by 1, negative 4.5 minus 1 is negative 5.5. Negative 5.5. Now let's simplify to get the final answer. So the derivative is equal to 4 secant squared y as it is. Then we have a minus. So for the second term, if we multiply numerator with numerator, that's 1. That's how we multiply the fraction. Then we multiply denominator with denominator. So 6 times 2 root y is 12 root y. And then plus, you have a 54. If we take it to the denominator, right? If we take this one, y raised to negative 5.5 to the denominator, it will be a positive exponent. So y raised to 5.5, y raised to 5, and square root of y, because the square root of y is a power half. So that 0.5 part is this one, and y raised to 5 is here. And when you write in the denominator, everything will be positive. So that is the derivative of the function, which is given up here. Okay, so in order to solve this problem, what we use is we use the power rule. We solve this problem using the power rule. That is the first example. Now, let's move on to second example for today. Here is example 2. It's a very, very famous question in Calculus 1, finding the equation of tangent line. So here we are asked to find the equation of line. Okay, we have to find the equation of the tangent line to the graph of this function. Here is the function. The point is already given at the point pi squared comma 0. In order to find the equation of the tangent line, we need the point and the slope. Point is already given. We need the slope. Slope is the derivative of the function at the given x value, that is at x equal to pi squared. So we find the derivative and evaluate at pi squared to get the slope. So let's begin that part first. So here we have our function f of x equal to sine 3 times square root of x. So we find the derivative. So the derivative would be equal to, okay, this is a composite function, so we have to use the chain rule. First, we find the derivative of outside function. Derivative sign is cosine, keeping the inside function same. And we multiply by the derivative of inside function. 3 is a constant, and then the derivative of the square root of x is 1 over 2 root x. Now, this is the derivative. So I don't want to simplify this right away because I need the slope. So I'm going to find the slope by plugging in pi squared for x. So slope will be, okay, slope denoted by m will be equal to cosine of 3 times the square root of the value of x is pi squared, okay, pi squared, then 3 times 1 over 2 times the square root of pi squared. So this can be simplified to cosine, let's see, cosine 3 pi, because here square and square root cancel, so that becomes 3 pi. Then multiply 2, if I multiply 3 with 1, that is a 3, and in the denominator we have 2 pi, because square root of pi is square and square root cancel, that's a pi. And now what we know is cosine 3 pi is a negative 1. So negative 1 multiplied to 3 pi over 2 is negative, 3 over 2 pi is equal to negative 3 over 2 pi. So that is the slope. Now we have the slope, we have the point. So we can easily find the equation of the tangent line. Let's do it here at the side. So the point slope form, we have the point and the slope. Now equation of tangent line will be equation of tangent line. Equation of tangent line is y equal to m times x minus x1 plus y1. Remember this point given here is our x1 comma y1. So we have x1, y1, we have the slope. So all we need to do is plug in here and simplify. So y is equal to, slope is negative 3 over 2 pi multiplied to x minus x1 is pi squared plus y1 is 0. Over here, y1 is 0. So that means we get y equal to, if we multiply this, we get negative 3 over 2 pi times x, and then negative and negative will be positive, and 3 multiplied to pi squared is 3 pi squared, and in the denominator we have a 2 pi, which can be simplified to y equal to negative 3 over 2 pi x plus, so here one of the pi's get canceled, so we get 3 pi over 2. 3 pi over 2. So that is the equation of line tangent to the given curve at a given point. So always remember, in order to find the equation of the tangent line, we need the point. If the complete point is not given, when I say complete point, point in the form of ordered pair x and y, if only x value is given, you have to find the y value. So we need the point. And once you have the point, we need the slope. Like here we got the slope equal to negative 3 over 2 pi. And the way we get the slope is the derivative of the function at a point. So you first find the derivative and plug in the x value to get the slope. So once you have the point and the slope, then we can use the point slope form, which is here. Okay, point slope form of the equation of a straight line to get the equation of tangent line. Okay, that is our second example. Let's move on to example 3. So here comes the third example for today. This one is we are asked to find the derivative of the function. Really, really simple. Look at this. Your function is f of x equal to 4 times e to the x. The derivative is written as f prime x equal to 4 is a constant. So if you use the constant multiple rule, so 4 will remain as it is. And the derivative of e to the x is also e to the x. That's it. So you can see that the derivative of the given function is the function itself. In this case, derivative of 4e to the x is 4e to the x, because the derivative of e raised to x is e raised to x. Okay, let's quickly move to fifth one. Here's our fifth example. So here we have a function f of z equal to -7 multiplied to 5 raised to z. Okay, -7 multiplied to 5 raised to z. So I want to remind you of formula here. If we want to find the derivative with respect to x of b raised to x, then the derivative is natural log b times b raised to x. That is the formula. If you want to find the derivative of b to the x, it is equal to natural log b times b to the x. So that is exactly what we'll be using here. So if we do that, you can see that the derivative is equal to, we write f prime z, the derivative. -7 is a constant. We keep it as it is. Okay, -7 is a constant. We keep it like that. Now, to find the derivative of 5 to the z, it is just like b to the x. So first we have natural log of 5. Okay, natural log of 5 multiplied to 5 to the z. So that is the derivative of that function. -7 natural log 5 times 5 to the z. There is nothing to simplify there, so we can leave it as it is. Okay, so this was the fourth example. I said 5, but this is fourth example. The previous one was third. This is fourth example. Okay, let's look at next one, which is also very simple. Here is that, example 5. We have a function f of w is equal to 5 natural log w plus 13. Let me write that function. So here, my function is f of w equal to 5 natural log w plus 13. So the derivative would be 5 is a constant. So constant multiple as it is. So we write that. Derivative of natural log w is 1 over w. And then plus the derivative of 13 is 0. That means what we get is the derivative is equal to 5 times 1, 5 over w. That's it. We don't need to simplify any further. That's all we can simplify. So that is the derivative of that given function. So that was the fifth example, by the way. So you can see that so far we are looking at very simple problems where we use the, basic formulas and rules, right? We need to know some of the basic formulas in order to find the derivative. Like you need to know the formula for b to the x, the derivative of b to the x. You need to know the derivative of natural log will be 1 over x, things like that. So we can basically use the formulas and rules to find the derivative of the function. Okay, example 6. This one involves a little bit of math. So what they have given is they have given a function which is in the form of a quotient. So f of y is equal to 18 times the sixth root of y. Sixth root of y is y raised to 1/6 over the natural log y. And you can see that this is in the form of quotient, one function divided by the other. That means in order to find the derivative of this, we use the quotient rule. And this is how we use the quotient rule. Okay, I'm going to write in detail. So the derivative is equal to denominator, which is natural log y, denominator times the derivative of, derivative of numerator. Derivative of numerator is 18, y to the 1/6. Denominator times the derivative of numerator minus numerator, 18 y to the 1/6 times the derivative of denominator. Derivative with respect to y of 1 over y. Okay, denominator times the derivative of numerator minus numerator times the derivative of denominator, all divided by the square of the denominator. So we have natural log y squared. Now we need to simplify this carefully. because we want to find the derivative. So we really need to simplify this very, very carefully to get that derivative. Okay, so this implies the derivative would be equal to, I'll write the numerator there. So we have the natural log y as it is. And then if I want to find the derivative of this one, what I need to do is I need to use the power rule. So if I use the power rule, this 1/6 will come in front and multiply with 18. So 1/6 of 18 is a 3. So that will be 3. And then y raised to, we reduce the power by 1. 1/6 minus 1 is negative 5/6. Negative 5/6. And then minus, we have 18 y raised to 1/6 multiplied by the derivative with respect to x of 1 over y. The derivative with respect to x of, hold on, this is natural log y. So I missed that. I already wrote the derivative. Let me just rewrite this. Natural log y, which will be 1 over y. So one more time, look here. Denominator times the derivative of numerator minus numerator times the derivative of denominator. Derivative of denominator, that will be 1 over y. And then we are dividing that by the square of the denominator. Natural log y squared. Now we need to simplify this carefully to get the final result. So let's simplify here at the side. This implies the derivative f prime y is equal to, you can see that we have 3 times natural log y, because this one, 3 times natural log y times y to the negative 5/6 minus 18. So here we have y to the 1/6 over 1 over y. So here also what we do is, if we want to simplify this using the laws of exponent, we reduce the power by 1 because this is the power 1. So 1/6 minus 1 is negative 5/6. Y raised to negative 5/6 over, in the denominator we have natural log y squared. So we'll be able to, in the numerator, we'll be able to factor this y to the negative 5/6. So y raised to negative 5/6 is factored out, and we get 3 natural log y minus 18 over natural log y squared. So finally, our answer will be, so you can see inside the parenthesis, we have 3 times natural log y minus 18. Okay, 3 times natural log y minus 18. If we move this quantity to the denominator, it will be positive. So that will be y raised to 5/6. And in the denominator, we already have natural log y squared. Natural log y squared. So that is the answer. So we use the quotient rule to find the derivative of the given function. So remember, if you have a function divided by the other function, and both the values in the numerator or both the functions in the numerator and denominator have the variable, you can use the quotient rule. And quotient rule says denominator, the derivative of this function will be equal to denominator times the derivative of numerator minus numerator times the derivative of denominator, all divided by the square of the denominator. And this rule that we have used here, one more time, that is called the quotient rule. Okay, that is 6th example. Let's move on to 7th example. So here you can see that we are asked to find the derivative by implicit differentiation, because this function given here is implicit function. You cannot find the value of y explicitly. That's why this is called the implicit function. Okay, and then your answer could be involving both x and y. That's very true. One thing to note here, I'm just going to give you, the power rule. What we know is, if you want to find the derivative with respect to x of x to the n, the power rule says n times x to the n minus 1. But if you want to find the derivative with respect to, with respect to x of y to the n, You want to find the derivative with respect to x of y to the n. In this case, the power rule will be a little bit modified. We use the power rule n times y to the n minus 1, but we multiply by the derivative of this inside function, derivative of y with respect to x, which will be dy over dx because of the chain rule. So that is what we'll be using here in order to find the derivative using the implicit differentiation. If it is just the function of x, the regular power rule works. If we have a function that is a function of y and you are differentiating with respect to x, at the end you have to multiply, you do the regular derivative, and at the end you multiply by dy over dx. So let's see, we have this function here, which is x squared y minus 6 times y raised to 6 equal to negative 9. Now, if you want to find the derivative, see, this one is the product of two functions. So in order to find the derivative of this first term, we have to use the product rule. Product rule says first function, x squared, times the derivative of second, dy over dx. Derivative of y with respect to x. First function times derivative of second, plus second function is y multiplied by the derivative of first. Derivative of x squared is x squared with respect to x is 2x. Then minus, we have this 6, which is a constant. Now we have to find the derivative of y raised to 6 with respect to x. That means this is where we'll be using the second one. We find the derivative using the power rule. That means this 6 will come in front and multiply. So in fact, 6 times 6, that will be 36. I can write like that. 36, and then y raised to, you reduce the power by 1. Y raised to 5. Then at the end, we multiply by dy over dx. Dy over dx is equal to the derivative of negative 9 is 0. So what we did is we differentiate on both sides with respect to x. Okay. Now in the first term and the third term, we have dy over dx common. So we can factor that out, dy over dx out. So from the first, we have x squared. And from the third, we have minus 36y to the 5. Then the next thing we can do is this one is without dy over dx. I can move it across. So that will be minus 2xy. Right? If we move that to the right-hand side, it will be negative. Now to find dy over dx, we have to multiply on both sides by this quantity. So we get the derivative dy over dx is equal to, on the right-hand side, we have negative 2xy over x squared minus 36 y to the 5. Or if we just simplify that, dy over dx is equal to, if you multiply the numerator by negative, or if you change the sign in the numerator, it will be 2xy. And if we change the sign in the denominator, it will be 36y to the 5 minus x squared. Because we don't want to have negative sign in front, that's why we multiplied both numerator and denominator by negative 1, and we get this. So that is the derivative of the given function. And here we use the implicit differentiation. Okay, so one more time, if you are using the implicit differentiation, remember that when you use the power rule, the derivative of x to the n with respect to x is n times x to the n minus 1. But if you are differentiating y with respect to x, you use the regular power rule, but at the end you multiply by dy over dx because of the chain rule. So that's how we can use the implicit differentiation to find the derivative of implicit functions. Okay, now finally, we are in this problem, still an implicit function, but it involves a little bit more math compared to the previous one. And this is going to be the last example for today. So if we look at this equation, here is a negative, here is a negative, on the right-hand side also negative. So what I can do is I can safely multiply on both sides of the equation by -1 and make everything positive. So that's where we can start. So we have, if we multiply the first left-hand side by -1, it will be x squared over u squared, then plus cosine 9u equal to positive 2. So all negative becomes positive. So here we have u. So remember, if you are differentiating x, okay, derivative with respect to x of x to the n is n times x to the n minus 1. But when you're differentiating with respect to x for u to the n, then it will be n times u to the n minus 1 multiplied by du over dx. So that is what we need to do. That's what we need to do so that we'll be able to find that du over dx. So now the first term involved the quotient. You have a variable in the numerator, variable in the denominator. So what we need to do is we need to use the quotient rule to find the derivative of this part. And quotient rule says denominator, which is u squared, denominator times the derivative of numerator. Derivative of x squared is 2x. Okay, denominator times the derivative of numerator. Minus numerator is x squared times the derivative of denominator, derivative u squared with respect to x. Remember, we have to use this second rule, which will be derivative of u squared is 2u, and then you have to multiply by du over dx. And we divide by the square of the denominator. The square of u squared is u to the 4, like that. So we get the derivative of this first part. Now let's go to the second one. This one, we have to use the chain rule. Okay, derivative cosine 9u will be negative sine 9u multiplied by the derivative inside function multiplied by 9. But you are differentiating u with respect to x. That means here we have to multiply by du over dx. And then that is equal to the derivative of 2 is a 0. So that's how we can find the derivative in first step. So we use the quotient rule for the first one. For this part, we use the chain rule. And this one, the derivative constant is 0. So always remember, if you have more than one variable, you will be using the implicit differentiation, the rule for the implicit differentiation. Now, in next step, I'm going to move this quantity to the right-hand side so that this quantity becomes positive. So we can write this as, over here, it will be 2x times u squared, which can be written as 2x u squared, and then minus this one, 2x squared times u, 2x squared times u, multiply with du over dx, all divided by u to the 4, is equal to, okay, this is equal to, I'm moving this quantity to the right-hand side, so that becomes positive 9 times sine 9u times du over dx. We need to find du over dx. Du over dx is in the left-hand side. It's also in the right-hand side. First, I want to get rid of this u to the 4, which is dividing in the left-hand side. So what we'll do is we'll multiply on both sides by u to the 4. If I multiply on both sides by u to the 4, on the left-hand side, you can see that u to the 4 get cancelled. So we are left with 2x u squared, 2x u squared minus 2x squared u times du over dx, which is equal to, okay, 9 times u to the 4. Let me multiply that first, which will be 9u to the 4, 9u to the 4 sine 9u times du over dx. So in order to find du over dx, we need du over dx on one side. So I'm going to move this second term to the right-hand side, so that becomes positive. So what we get is 2x u squared will be equal to 9u to the 4 sine 9u du over dx is already there in the right-hand side. And we are moving this one to the right, so that'll be positive 2x squared u times du over dx. Now we can easily simplify. Okay, so this implies, let's see what we get. On the left-hand side, we have 2xu squared, 2xu squared equal to, on the right-hand side, I can factor this du over dx out. Okay, du over dx is factored out. Then what is left in the first term is 9u to the 4 sine 9u, 9u to the 4 sine 9u, and then plus in the second term when I factor this, we are left with 2x squared u, 2x squared u. So if you want to find the final answer, the derivative du over dx, we have to divide this quantity by that one. So we can write du over dx is equal to 2x u squared divided by 9u to the 4 sine 9u plus 2x squared u. Okay, so you can see that this problem involves a lot of simplification, but what we are doing is we are just using the implicit differentiation and we are calculating the derivative of that function. One more time, remember when you're calculating or when you're working on implicit differentiation, you have to be very careful with the power rule. If you are differentiating a function of x with respect to x, you just use the regular formula. But if you are differentiating some other function with respect to x, then you have to multiply by the derivative at the end. Like u with respect to x, we multiply by du over dx. And even the previous example, if you are multiplying or if you're working on a function of y with respect to x, then we multiply by dy over dx. So this is how we can solve some basic, very simple type of derivative problems. That's what we did in this video today. I hope you found this video helpful, right? You find this video helpful. So thank you so much for watching, and I hope to see you again in next video.